In this video I'm using a modified Softrock ensemble. Here the gain of the op-amps is reduced by about 10 dB. And there are also some capacitors to reduce or maybe even remove phase noise on the local oscillator on the SI570. I have set the signal level to -8 dBm and then calibrated the S-meter to make it show -8 dBm. I have connected this crystal oscillator, which is very good, through this attenuator and through a second attenuator, which right now is set to 0. And then the signal level I see is -8.1. That is close enough to -8. The sound card is a Lynx 2 and I'm using the ACO driver. The MME driver does not work on this system. The purpose of this study is to look at the noise floor while the strong signal is present. That means, is there a reciprocal mixing problem that contributes to the noise floor? Well, for the Lynx 2 certainly there is. This is the noise floor, about 10 kHz from the strong signals, and I switch it off and you can see it's something like 5 dB. And I put back the strong signal, and now I will step the frequency to see at what separation, I mean what larger separation than this, the noise floor has its worst value. And here is some local interference. I don't care about that really. But here the noise floor is higher. And now it goes down again, so the worst frequency separation is about 100 kHz. And of course I have to avoid this local thing. But the noise floor of the Lynx 2, when there is a strong signal, is about this much, -120. It's not at all as impressive as one would have thought from the data when there is no strong signal present. If I switch off the strong signal again, you see there is nearly 10 dB of reciprocal mixing, and that is in the sound card. -128.5 for the sound card without the strong signal, and with the strong signal about -120. I think I looked at it recently, but I repeat it from here to here, -121 dBm, and the bandwidth is, as usual in this series of tests, is 1 kHz. The purpose of this study is to look for reciprocal mixing in the AD converter of the sound cards. I'm now on the signal and I have set the stepping to 5 kilohertz. So 5 kilohertz away, you can see the noise floor is something like -121, and I step further in steps of 5 kilohertz to look if there is some particular frequency where the noise floor is higher. And it goes down as I go further away, which is normally expected. Now on this frequency there is a spur. But this is not a spur, it's a noise. I have to change the... no, I don't. I can look at the spectrum here. There are no spurs, it's just the noise. And we can see here in the main screen. So the noise is now at -120 dBm approximately. And I am about 65 kilohertz away from the carrier. And it's a wide range noise, but now it starts to go down. I'm up at 14,295 on this scale, 160, 260, 135 kilohertz above, and I go rapidly further upwards to see if there is any big surprise. No. 14.16, I think it was. No. 14.17, here we are. So what I found is reciprocal mixing noise of this sound card is -120 dBm at this signal level. But you can see here, suddenly there is something we don't like. This is noise coming and going. I don't know the reason for it, but it disappears completely with just a small frequency step. This could be the local FM station that enters the box somehow. It could be something else. This is what I see when there is nothing connected to the Lynx 2. Many spurs, but the noise floor is at -135. Means the dominating noise I have seen really comes from the Softrock ensemble, and it would be possible to reduce the gain even a bit further with this sound card, and that would mean the unit could tolerate stronger input signals than -8 dBm. But it would be meaningless because reciprocal mixing is the limiting factor. So it just shows very good things are possible, but not with this sound card. I have now changed to a M-track quad. The signal is still -8 dBm, and I adjusted the S-meter to show that correctly. And then I look about 10 kilohertz away and find the noise floor at -116.8. This is the close range noise floor, and I go away in frequency. When we have 160 here, or 160 here, means we are on the signal. And I go upwards to look for worse noise floor at larger separations. Because reciprocal mixing may happen when the strong signal is well outside the visible passband. But I don't see any increase yet. The actual sampling is probably at the 64th overtone, something 6 megahertz. So signals that can go through the low-pass filter of the Softrock will go into the digital part of the AD converter. But I don't see any problem. I go back to 14.25 and look at the noise floor at a wider separation. And here I find minus 117 dBm. Now I have connected a DMX 6 Fire USB box. On the signal, the level is minus 8 dBm. That's really the level we have. And I step upwards in step of 5 kilohertz. And already 5 kilohertz away, it's better than minus 120. And I go further on. And this looks very interesting. But here the noise floor is going up. Oh, not really. So I look for the noise floor at 20 kilohertz separation. Which is kind of standard. No, this was 10 kilohertz. 20 kilohertz. But there is a spur here, so I go up to 25. And read out what is the reciprocal mixing noise for. It is minus 123.2. Now I have changed to the Complete Audio 6. The level is still minus 8 dBm and Linrad is calibrated for that. The main spectrum does not look very nice. I switch off the signal and you can see how the noise floor goes down very much. I step up 5 kilohertz and here you can see the noise floor of this modified Softrock. And I put back the signal and here is the reciprocal mixing 5 kilohertz up. 10, 15, 20. So at 20 kilohertz it is, what do we have? From here to here, minus 104.8, that's minus 105. But we have these ugly, fairly wide noise humps. And I think it's fair to look at the frequency where they are, like this. And here the noise floor is at minus 80 dBm only. And I continue upwards. And we have more of these noise humps. There is another one. And I'm not exactly on it, but that doesn't matter. Here is yet another one at minus 95 dBm. And I continue upwards in frequency. And now I don't find any more things. So reciprocal mixing is fairly near to the signal, but extends over, was it 100 kilohertz or so, with several strong noise humps. So this is not the recommended sound card as I see it. Nothing to use for software defined radio. Oops. So I rate this card at minus 80 dBm because of this fairly wide noise hump. I think such things should not occur in a radio. It is of course possible that this box is faulty, but I don't want to buy another one to compare with.